Welcome and hello. This is a video exercise in HEC RAS, and in this exercise, we are going to be dealing with restart files. In HEC RAS, restart files are used to establish initial conditions for subsequent simulations by storing water surface elevations from a previous run. All right, so to demonstrate what that is, let's go ahead and get started with the exercise. I'm going to start by going File, New Project, and then navigate to the directory I want to start this project in, right here. And then I'll give the project a title. I'm just going to call it Exercise 12. You can call the project whatever title you want, and click OK. All right, next I'm going to open up my geometric data editor, and then click on River Reach, single left click, and then a double left click to end the reach. And then let's give the river and the reach a name. Cross section, I'm going to go Options, Add New Cross Section, 0. So I'm going to define the cross section at the downstream end of this river reach, which is River Station 0. I'm going to keep this real simple. I'll just go V-shape channel. So it's going to be, and then back up to 220. We'll have a preview of that in just a moment. This is going to be zeros. And then the Manning's N, I'll say 0.05. And then left over bank will be 0, right over bank will be 200. Okay, apply data. On the right here in the preview window, we have the triangular shaped channel. So that's going to go Options, Copy Current Cross Section. I'm going to say it's at River Station 100. And I'd have to type in a 100 here, and then here, and here. And then let's also increase the elevation just a little bit. So adjust elevation, 1 foot. Okay, so I'll go ahead and close that. Here is the river station. Here are the two cross sections. Next, I want to add a storage area. So I'm just going to do some clicks here, double click to end it, call it storage area 1. And then to define the geometry of that storage area, I'll go single left click, edit storage area. And then on my clipboard, I have the data saved. No, yeah, there it is. So it has an invert or a bottom elevation of the storage area at elevation 200 feet, where there's 0 volume. And then as the elevation increases, so does the volume. I'll click this plot volume elevation curve so you can get a sense of what that volume and elevation relationship is for the storage area. All right, now we need to connect the storage area to the river reach. So we'll do that using a lateral structure. I'll click on lateral structure and then Options, Add Lateral Structure. Now keep in mind this is 100 feet here. So what I think I'm going to do is have a lateral structure that's 60 feet wide with 20 feet from each of the two river cross sections. So that means the upstream end would be at 80 feet of the river station. It's going to be left over bank optimization. I'll check that on. Okay. Okay, we don't need steady flow analysis yet. And then it's going to go, the tailwater condition will be to that storage area 1. So go ahead and make that assignment there. Okay, everything else here is good. And let's go down to weir embankment. So let's see, the weir width, I would say we'll say 20 feet. Headwater distance to the upstream cross section, that needs to be 20 feet. Because like I said, it's going to be 80 and then down to 20 and then 0. So this right here is going to be 20. Now I need to identify the station and elevation to define the shape of that lateral structure. I'm going to start off at 0 and 200. That is the invert. And that is also the bottom of the storage area. Okay, so those are the numbers I typed in there. We should see that in the preview right here. That looks good. And I think that's all I have to do for the lateral structure. So let me just close that. And it looks like it appears and displays on the screen just as we want it. Next up, I'm going to define the unsteady flow data. So I'm going to come up here to Edit menu, Unsteady Flow Data, or I can just click on this button right here. And we need to define the boundary conditions. So first I'm going to do the cross section at River Station 0. I'll click on the boundary condition box and then normal depth. This is a 1% slope, so we'll type in 1% and click OK. The boundary conditions for the upper cross section at River Station 100, I'm going to use a flow hydrograph. So I'll click this box, click flow hydrograph, and I'm just going to enter the data directly in this table here. Fixed start time is what I'm going to select, and this is going to be for the first 30 days of 2020. So that'll be 01 January 2020. I'm going to say the start time is 0 o'clock. So that's midnight. And at an hourly time step, I'll use that 1 hour. If it's 30 days, that's going to be 720 hours, and the number of default ordnance is only 100. So I'm going to just increase that number to 723. I think I need 721, but I wanted to add a couple extra just to confirm. So I'll click OK. Now I have 723 rows in this table. And as you notice, the date time here does start with the date time that I told it to start at up here. Over in Excel, I've copied some flow data onto the clipboard. So I'm going to bring it in here, highlight all the cells, and then right click. Okay, that didn't do anything. How about Control V? Great. Control V worked. And what I'm doing is I'm just starting at 0 flow and I'm increasing the flow in CFS at 10 CFS every hour for 30 days. Now, what I'm going to do in the simulation is break it up into 3 parts. First 10 days, second 10 days, third 10 days, saving a restart file, and then using that restart file as the initial conditions for the second and third 10-day block durations. I have also noticed through trial and error that leaving this first time period at 0 right here is problematic. So I'm just going to change that one to a 10. And all right, I think we're going to be on our way. So it'll start at 10, and then it'll start ramping up 10 CFS every hour. All right, so that's good there. If you want to plot the data, you can actually see it really does ramp up from 10 CFS all the way to what would be 7,200 CFS after 30 days. So after the first 10 days, it's going to go basically from 0 up to 2,400. And then the next 10 days, it'll be 2,400 to 4,800, and then 4,800 up to 7,200. So close that, click OK. I'm going to save this plan file or this unsteady flow file as days 1 through 10. And the reason is for the initial conditions, I forgot to mention, this storage area 1 here is going to be set to its initial value of 0, or 0 volume, which is an elevation of 200. So I can type in 200 there, or if I delete it and just click in this button to import the minimum storage area elevation, boom, 200. So for the next unsteady flow data for days 11 through 20 and also 21 through 30, then I'm not going to be using this radio button for enter initial flow distribution or the storage area elevation. What I'm going to do is use a restart file, which I'm going to be generating in the previous simulation. So this first simulation here, we're starting with a fixed known water surface elevation in the storage area, and that's 200. But then in the second and third simulations, I'm going to use a restart file that's generated from the previous simulation. Now I still need to tell HEC RAS to write that restart file. That's coming up as well. So file, save unsteady flow data. We're done with this. Let's go ahead and click on the run unsteady flow analysis. And what I have here for the geometry file, oh, I still need to save that. Hold on. So let me close this file, save the geometry data. It's going to be the same geometry data for the entire exercise here. So I'm just going to call it base. Okay, so there's base. Again, let's go back to run unsteady flow analysis. Okay, great. Now we have base in days 1 through 10. For the plan, I'm going to save this as days 1 through 10 as well. So save plan, title, days 1-10, and okay, days 1 through 10. Okay. And then here's the important part for creating a restart file. Click on the options and then come down to output options. This first tab here, restart file options, this is where we want to put a checkbox right here. It's going to create a restart file, which saves the state, specifically the water surface elevation of the simulation at the end of this particular compute. The checkbox up here allows us to save the state at some intermediate points and then multiple intermediate points if we want. I'm not going to do that. I think this is a little bit more common right here. So I'm just going to check that box, click OK. Got a few more things to do here before we can compute. I'm going to go ahead and check on geometry preprocessor, unsteady flow simulation, and post processor. Now for the starting date time, that's going to be 0 January 2020. And then the starting time of day will be midnight. And then the ending date will be 10 days later. So that'll be the 11th at midnight. And everything else down here looks good. Just before running compute, I wanted to show you the project files. So right here, we don't have any .rst files yet, but that will be generated at the time I click compute, along with the output file and I think a few other files. So let's go ahead and give that a shot. Let me file, save the plan, and click compute. All right, so it appears to be running. Okay, and then I'll click close. Let's go ahead and look at that directory now. We have a bunch more files. Of course, we have our output DSS file. Here's an output file. Here is our .rst file, and it's saved with the title of the plan or the project exercise 12.p01. And then here is the date time. And then 2400 hours right here represents midnight of January 10th, which is the same thing as 0 hours of January 11th, which is where we're going to be starting our second simulation for the second plan. And we'll be using this .rst restart file for our initial conditions. All right, let's go ahead and take a look at some results real quick. So the results I'm most interested in here is the water surface elevation in the storage area. So let me close that. So we have flow that's increasing and increasing and increasing. Slowly, the storage area is going to start filling up from elevation 200 up to something else. Let's check out what that is. So view, stage and flow hydrographs. Okay, so we have a few things here. I'm going to go type, storage area. Okay, I'm going to toggle off the flow. Here is the water surface elevation in that storage area 1. So it's highlighted in magenta here. It starts at 200 and it quickly fills up to, looks like about 208.51 after 10 days. We can look at a lot of other data, and I will briefly, but I don't want to lose focus on the purpose of this exercise, which is the restart files. View, if we want to look at the water surface profiles, here we see the water surface profile. Of course, you see the lateral structure, which is right here. And if I wanted to animate this over the course of the 10-day simulation, options, animate, we can see the water surface rising from 200 up to, what was it, 208.5, which is right about there. Okay. All right, let's go ahead and create a second plan and run the simulation a second time for days 11 through 20. To do that, we need to create a new flow file or edit unsteady flow data. I'm going to go ahead and just file, save unsteady flow data as, and instead of 1 through 10, I'm going to go 11 through 20 now, and then click OK. I'm going to use the same flow hydrograph, the same normal depth for boundary conditions, but then in this initial conditions tab, what I'm going to do is disregard this 200-foot starting elevation for the water surface elevation, click on this restart file, and then navigate to that file. So it's over here. Here it is, .rst. So if I click on that, I'm good to go. File, save flow data. Now let's go back to simulate, which is run unsteady flow analysis right here. Okay, cool. So it's using our base geometry file again. It's using our most recently created and saved unsteady flow file, which has that restart file associated with it. What I need to do next is change this from January 11th at midnight to the 21st at midnight. And then everything else here looks good. Now I want to save this plan as days 11 through 20. So file, save the plan as days 11 through 20. Okay, and okay. Let's give this a run and then see what sort of results we get. Okay, that looks successful. I'll click close now. And again, I'm going to head straight to the water surface elevation in our storage area. Take a look at that first. View, stage and flow hydrographs. Okay, it started me off on lateral structure again. And now here is the storage area. And that's exactly what I wanted to see. We're seeing at the beginning of January 11th, the water surface elevation begins right here at 208. And then over the course of the next 10 days, it looks like it increases up to 211 almost. It looks like it's 210.9192. So that's awesome. Let's go ahead and look at the water surface elevation in the main channel. That's View, Water Surface Profiles. Okay, and so let's check out the plans here. I'm going to toggle on both plans, see what that looks like. So both of these should be increasing when I go ahead and animate. Options, animate, and then play. Okay, cool. So the bottom line is days 1 through 10. The top line is days 11 through 20. All right, well, I could do another iteration and run a simulation for days 21 through 30. Use the restart file as my initial conditions that I did generate. Let's double check that I generated another restart file. Yep, I did. It's right here. So this is for January 20th at midnight, which is the same as January 21st at the very beginning of the day, midnight. And then we could continue that process on and preserve the water surface elevation in the storage area or any other structure that happens to be in your HEC-RAS model.